I'm Betsy Karle, and I'm pleased to share our survey of wildfire ash impacts on California's forage crops, where we ultimately found that toxicology results of the forage sampled were pretty unremarkable. Heavy metal loads were low or non-existent, and ultimately leading us to the conclusion that forages impacted by wildfire ash were safe for livestock and dairy to consume. In the summer of 2018, we were faced with cornfields that looked a lot like these pictures you see here, covered in a thin layer of ash from wildfires surrounding the area. Later in the season, in November, a very devastating fire impacted the Paradise area of our Northern California region, leaving behind devastation, as you can see in these pictures, and emitting who knows what compounds into the soil, air, and water throughout the region, and dropping really large pieces of ash into our forage fields with no answers as to what might be toxic compounds in that material. So we decided to start sampling, and we sampled after the fire season started in summer, looking at pastures, hay, and corn silage fields. We analyzed these samples for heavy metals and minerals. We have the minerals highlighted here on this list in yellow. We had those analyzed at a commercial lab and used the maximum tolerable levels listed in the NRC as a guideline. We also sampled heavy metals, so those are highlighted here on this list in green. We also added arsenic to that suite of heavy metals that we sampled for. On some of the samples, we did mass spectrometry, where we were looking for organic chemicals in these forage samples, any number of organic chemicals belonging to diverse chemical classes. So these could be pesticides, environmental contaminants, drugs, lots of other natural products, and these samples were analyzed at our UC Davis California Animal Health and Food Safety Lab. When we got our samples back, we were pleased to see that we did not detect any lead, mercury, arsenic, or cadmium in any of these forage samples, and we're getting back pretty low levels of manganese, iron, zinc, copper, and molybdenum. Looking a little bit at those samples that we did get some hits on, the range was pretty variable. We did have a few samples that were almost outliers on the high end, but very inconsistent as to where those samples came from and what forage type they were. The median and the mean on all of these samples were certainly within the maximum tolerable levels as established by NRC. Looking a little closer at some of these heavy metals, we did notice that we had some differences amongst forage type as we looked at the heavy metals that we did have positive results for. But when we look at that, at these samples as to whether they were in areas that were impacted by ash or not, those differences kind of disappear, except in the case of copper, where we found that copper in samples that were from areas not impacted by ash were actually significantly higher in copper levels. Looking at the minerals, we see a little tighter range and looking at these minerals, and again, our medians and our means well within our maximum tolerable levels. Only potassium on few samples on the high end that were a little bit above our maximum tolerable level. For our mass spectrometry, we did this on a subset of the 37 samples of our total of 61 samples, just to kind of get an idea, really target those areas that were certainly impacted heavily by wildfire ash. And we did get some positive results, but as you can see, only a few positives out of those 37 samples, and not any consistency that we could see relative to forage type or how those areas were impacted by the fires. These could be naturally occurring plant compounds. They could be legacy types of compounds. None of these results led us to believe that this was an area of concern that could be specifically attributed to the wildfire ash in the area. At the end of the day, our toxicology results were mostly unremarkable. We did not find any lead, mercury, arsenic, or cadmium on the heavy metal end of things, and the other heavy metals that we did detect were mostly in low concentrations, leading us to conclude that forages impacted by wildfire ash should be considered safe for livestock to consume. Big thanks go to the project team and funding agencies. Many hands made this work possible. I appreciate your interest in our work and look forward to addressing any questions. Thank you.